Hello, in this video we'll look at matrices. We'll first look at addition, subtraction, multiplication, finding the determinant and the inverse of a matrix. So let's see on addition of matrices. So under addition, two matrices can be added if they have the same order. If they have the same order, like I said. For example, if we have this matrix being added to this matrix, these two can be added because they have the same order. This is a 2 by 2 matrix and this is a 2 by 2 matrix, so we can easily add them. 1 plus 0 to give you 1, 2 plus 1 to give you 3, 3 plus 2 that will give you 5, and 0 plus 1 that will give you 1. So that's how you can add a matrices. Let's look at one more example. If we have 0, 1, 3, 2 being added to 2, 1, 5, 6. So these two can be added because they have the same order. The first one is a 2 by 2 matrix and the second one is also a 2 by 2 matrix. So we are saying it's 0 plus 2. So 0 plus 2. And it's 1 plus 1. 1 plus 1. Then it's a 3 plus 5. 3 plus 5. Then it's 2 plus 6. 2 plus 6. And the resulting matrix is 2, 2, 8, and 8. So that's how you can add two or more matrices. Let's look at subtraction. The same rule when adding are the same rules when subtracting. So under subtraction, for example, if we have this matrix being subtracted from by our resulting, it will be the same order. So it will be 2 minus 2, that is 0, 5 minus 1, and that will give you 4, and it will be 0 minus 7, that will be negative 7, of course. Then it will be 2 minus 3, that will be negative 1. So that's how you can subtract. So it's the same order as when adding matrices. Let's look at one more example. So let's look at this example. So here we go. So it will be 3 minus 5. 3 minus 5. Then it will be 5 minus 7. 5 minus 7, cross brackets. Then negative 1 minus 6. So negative 1 minus 6. Then 2 minus 1, that is 2 minus 1. And this will give us 3 minus 5, that's negative 2. 5 minus 7, that is also negative 2. Then we've got negative 1 minus 6, that is negative 7. Then 2 minus 1, that will give us 1. So that's how we can easily subtract two or more matrices. Let's look at multiplication. So when multiplying matrices, you need to know that we always multiply a row by column. So for example, if we have this being multiplied by, we can multiply this one easily. So we first start with the rows, then columns. So it will be 1 times 2, 1 times 2. Okay. Then it will be 1 times 5, 1 times 5. Then 2 times 2, again 2 times 5. And the answer will be 2, 5, 4, and 10. Because we are multiplying rows by columns. Let's look at another version of this. So let's look at this example. So we'll go is 2 times 1 times 1 times 2 times 1 times 2 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 times and it is also, since the same row is multiplying the same columns, we add then 1 times 8. So and that will give us 2 plus 8. That will be 10. So let's look at this complex example. So it will be 1 times 2, 1 times 2 plus 2 times 0 plus 2 times 0. We are done with this column. So we're going to go to the second column. So again it's 1 times 1, 1 times 1 plus 2 times 1, 2 times 1. Then we go now 3 times 2 plus 0 times 0. Then we go to 3 times 1 and 0 times 1. Hence we are going to have 1 times 2 is 2 plus 2 times 0 is 0. Then 1 times 1 is 1 plus 2. Then we have 6 plus 0. And we have 3 plus 0. So I can lab the bottom there. So we bring down and say 2 plus 0 is 2. 1 plus 2, that is 3. 6 plus 0, 6. 3 plus 0, we have 3. And we are done multiplying. Determinant. How do we find the determinant of a matrix? So if this is a matrix, we have this diagonal known as a major, and we have this diagonal known as a minor. So determinant is equal to major diagonal minus minor diagonal. So let's look at an example. How can we find the determinant of this matrix? So we are going to say it's 4 times 1, the major diagonal, minus the product of the minor diagonal. So 4 times 1 is 4, and 3 times 2 is 6. So as a result, our determinant is equal to -2. Let's look at this one more example. How can we find the determinant of this matrix? We know that the product of the major diagonal is 0 times 6, and the product of the minor diagonal is 2 times 1. Hence it's 6 minus 2, sorry, it's 0 minus 2, and our determinant will be equal to -2. So it's not that it will always be giving you -2. No, they are different negatives. Inverse of a matrix. How do you find the inverse of a matrix? First thing is you need to know the determinant. Second, you need to swap the order in the major diagonal, and you need to change signs in the minor diagonal. So these are the two key points that you need when finding the inverse of the matrix. Let's look at an example. How can we find the inverse of this matrix? Let's say this is matrix A. So the inverse of a matrix will be denoted by the power -1. It means the inverse. First thing, you need to find the determinant. And how can you find the determinant? Well, the determinant is the major diagonal minus the product of the minor diagonal. We're going to have this, and our determinant will be equal to -4. Step 2, like we said, you need to change, then you need to swap the numbers in the major diagonal, and you need to change the signs of the minor diagonal numbers. So we need to swap. So 6 goes there and 1 comes there. we change the signs for this, becomes negative 2 because that one is positive, and this one becomes negative 5. As a result, we say the inverse of matrix A is equal to 1 over the determinant, open brackets, then 6 minus 2 minus 5 and 1. If you want, you can proceed by multiplying this part with each and every number inside, or you can just leave it like that. Let's look at one more example. So let's look at this example. We've got matrix A, which is equal to x3, 2, 1, and they're saying the determinant of matrix A is 15, is 4. And they're saying find the value of x and find the inverse of matrix A. So to find the value of x having the determinant as 4, we know that it's x times 1 minus 3 times 2, that will give us 4. That's a determinant. So here we've got x minus 6, that is equal to 4. So x is equal to 4 plus 6, and hence x is equal to 10. So the value of x is 10. So we can now rewrite the matrix and say matrix A hence is equal to 10, 2, 3, and 1. Now how can we find the inverse? We have the determinant as 1 over 4. We have 1 over 4. We need to swap the numbers in the major diagonal, so 1 goes there and 10 comes there. We need to change the signs for them in the diagonal numbers. We have negative 2 and negative 3. We are done. So thank you so much for watching. If you have any question, please don't hesitate to comment, and please subscribe to my channel, PVS the Tutor.